Hello, welcome back. This is week 6 of IGB100, and basically we are just going to be continuing on from the work from last week where you set up a basic environment using the terrain tools and also dropping some kind of obstacle in there. In this case we put a house in. Now this lesson we're going to do a little bit to do with setting up an enemy. We're going to have a basic discussion about that enemy's AI and setting up some kind of navigation system for that enemy so that it can essentially chase you around this environment, which is going to lead into a bit of a talk about the placement of objects within your environment to make that gameplay element a little bit more interesting. So to get started with this enemy, I'm just going to make a new game object, 3D object capsule. I'm going to get rid of the mesh renderer on it as well as the mesh filter. I just want the capsule collider. I am also going to make its radius a little bit bigger. I think something about 1 would be appropriate, just so it's a little bit fatter. And we'll rename it to enemy, as well as give it the enemy tag. Cool. In addition to this, we're also going to attach it, give it a model file. We have an attack bot model in the models directory that you can use. You will need to make this a little bit bigger. It's kind of small. I'm setting it to 20 on the X, Y, and Z, as well as drop it by, let's say, negative 0.5 and rotate it by 90. That seems, no, negative 90 should be the correct rotation. Yeah. Okay. That's what our enemy is going to be set up to look like. The final thing we're going to do here regarding its setting up of components is actually give it the enemy script. Now this is a pre-made enemy script that you would have actually started from the previous game. It is a very similar setup to it. We're going to be adjusting it slightly to work more appropriately for this game. So the AI for this enemy is going to be pretty basic. We could do something slightly more complex in the sense of giving it line of sight detection or even an aggro radius, but for now we'll just make this incredibly simple in the sense that, like the AI in the previous game, it's going to move towards the player. We won't be giving it any advanced abilities besides maybe just bumping into the player and doing damage, but by the end of this tutorial series you will be able to implement weapons, animation systems, whatever you desire. That will not be a problem. The thing that is interesting about this enemy is that it's going to make use of Unity's inbuilt A-star navigation tool, which means that anything that you have placed on this terrain, such as a house, maybe some of the trees, to some extent the actual terrain itself, depending on its elevation and the angle that it's positioned at, will essentially become obstacles for both, well, you as the player and the enemy, giving you an interesting dynamic where if the enemy has to chase you, they're going to need to navigate around these obstacles as well. So you could potentially think of some interesting gameplay elements that could be the result of that. If you're going uphill, they're going to be going slower, for instance, because gravity will be affecting them to a degree. So to set up this navigation system for this enemy, we will need to apply a nav mesh to our terrain. So with the terrain selected, go to Window, Navigation. The navigation panel should appear somewhere in your UI. In this case I have it here on the right. Just with the terrain selected, let's press bake and see what happens. Now if you've done it correctly, a big blue nav mesh shall appear that will essentially dictate where your enemy AI is going to be able to navigate. You may notice, for instance, that the trees have already blocked out areas on the nav mesh, but your house, or whatever obstacle you may have modeled, may not. So in that case, we'll need to target that house model specifically, add a component navigation nav mesh obstacle to it, and in the inspector view, with that nav mesh obstacle component, just click carve. So when you look at the terrain again, its nav mesh settings, you'll notice that the house has carved a section out of that nav mesh as well. Now these objects can actually move if they happen to be, say for example, animating, and they will also carve the nav mesh in real time, which is a pretty powerful tool to have. So what you'll notice as well is that our nav mesh isn't perfect. If you kind of look at the perimeter of your arena, you may notice that certain sections of the nav mesh have been carved, made available to your enemy, when they're probably areas you don't want even yourself as the player to be able to navigate to. So what we might do in the navigation panel within the bake options is just reduce the maximum slope to maybe something like, let's try 35 degrees, and we'll bake that again. Now, that's still not perfect, but as you can see, it kind of reduced the amount of available terrain that this enemy has available to it to navigate on. Okay, so to make our enemy able to use this nav mesh, whether it be a plane or a terrain setup, we need to apply a component navigation nav mesh agent to this enemy. Now this is an interesting component with a few various variables that you can use to set how well it navigates on the nav mesh. For the moment we don't really need to play around with these too much at all, but we will need to set it up in the script that this enemy is going to use correctly so it actually understands what it is that we're trying to do. So opening up your enemy script in Visual Studio, the first thing I want you to do is add a library to the top of your script, which is using Unity Engine .ai. Following up from that, I want you to declare a new variable of type nav mesh agent. So that library above allows us to declare one of these, and we're going to fill this with the component that we actually have attached on our object. So within start, we're going to say that our agent equals a get component call to nav mesh agent. So essentially it's going to find the component called that on our current object. So what we're going to do here, in order for our enemy to acquire the player target, is we actually already have set up for you a public game object target. So this is going to be where the acquisition of the player makes sense. For this to work though, we're going to use a tag system. So the enemy is going to find a game object that's tagged as the player when it starts. So just quickly go back into Unity, tag your FPS controller as player if you haven't already done so. And in start, we're going to use an exception catching technique. So what we can say here is that we want to make the player reference, it's going to be an exception catch or catching. So we can try to do something that will be making target equal a game object dot find game object with tag. Make sure this is find game object, not objects. We are only looking for one, and that tag is simply going to be player. So if a player exists, make target equal to it. However, if we catch an exception where there is no player object or object tag with player, we then simply want to make target equal to null, which is what it currently is. So essentially don't change it, but don't throw an error at us. And that should work nicely. That'll acquire a player target for us very well. Moving on from this, let's make a method call to a new method called movement. and we'll just put that right below update. We'll make a private void movement, and in here all we're going to do is have a simple conditional that if we have a target, so if target is not null, then let's just make the agent, as in our component called agent that we have attached to our game object, make its destination equal to the target dot transform dot position. So if we have a target, make my eventual destination as an enemy that target's transform dot position. So move me towards the player. And that should be good to go. If we go back into Unity now, just again make sure your FPS controller is tagged as a player. Your enemy should hopefully travel towards you. Now it's going through the ground a bit at the moment. We might want to fix that, but as we can see, the enemy is moving towards us in the way we intended. So just to address that issue, if you look at your enemy, if you look at the NavMesh agent, you'll see that the cylindrical object that the NavMesh system uses for allowing agents to move around is actually offset slightly incorrectly. And I think it was because this base offset is set to 0. I might change that to 1 and just see how the game looks now. That's looking about right. So he's looking like he's pretty well flush with the ground at this point. Cool. So we currently have an enemy that will chase you. It won't exactly do damage to you at this point, even though we may have the script set up to support that within player. Currently players can take damage, currently players do have health, but there's a little bit there we need to set up to make that work correctly with the current FPS controller. There's also a little bit of a problem that when you die as an FPS controller, the camera disappears, so we actually need a system to make that camera active again. We'll do that next week. However, for the moment, let's think about how these enemies are going to spawn. So like in the game previous, we had enemies spawning from enemy spawners. So what we will need to do is, first of all, make our enemy a prefab. This is something that you might be becoming familiar with at this point. So make your enemy a prefab and get rid of your enemy within the scene and make a new empty, let's call it enemy spawner, and drop the enemy spawner script on it. Now this is the exact same enemy spawner script that we used in the previous game, however we're going to make a couple of additions to it. Now these additions are going to come in the form of spawning for a set period of time. For these spawners, for this survival based horde shooter, which is the kind of game that we're going to end up making here, we maybe only want enemies to spawn for a couple minutes at most. We won't set it that long for this initial test. We might set it to maybe 15 seconds or so. But to do that, we need to keep track of how long, not the game, but the scene with which this game is running for. So to do that, we're going to set that up in Game Manager. So open the Game Manager script in Visual Studio and make a couple of floats at the top of this. The first float will be a public float time, and that's just going to be the time that this instance of this scene has run for. It's different from time.time, but I'll explain that in a second. The other one is going to be a public float max time, and we might set that to a default setting of say, let's say 15. Now, what we want this scene to do is increase time. Now, do you remember back in the previous game where I discussed what delta time is? So delta time is the time between frames, which also means it's a great way to keep track of time, because there are there is time between frames, but the frames themselves only last for, no fraction of that time. So we could keep track of time effectively by saying that time is plus equal to time dot delta time. So that'll keep track of our actual time within the scene. Now this is different from saying that time is equal to time dot time, because time dot time keeps track of the time that the game has run for in total, whether that be in main menus, whether that be in multiple repeats of this scene. We don't want that. We just want the instance of this scene, as in this current session of play, the actual level that we're in, how long has that been going on for? And delta time, assuming you reset it back to 0 every time you restart, will do that pretty well. So that's what we want. So, going back to our enemy spawner, if you open that script up in Visual Studio, we can add a couple of extra conditions to the bit of logic that we had set up for spawning enemies here. And that's simply going to be asking the question if game manager dot instance dot time is less than the game manager dot instance dot max time. So the question we're asking here is, has this time exceeded the max time? And if it hasn't, then continue doing your thing. In this case, if we've been playing the game for 5 seconds and the max time is 25, then that's going to come out as being true, and every instance of this is going to come out as being true, therefore spawn an enemy. So as long as we haven't gone over the max time, which is in Game Manager, we will keep spawning enemies at the desired rate. So we can test this now. If we go back into Unity, find our enemy spawner, currently we're not spawning any enemy, so just drag your enemy into that. The spawn rate will be, let's leave it at 3. If we go to our Game Manager, max time at 15, should spawn 5 enemies and then stop, basically. Let's give that a go. That's 1 enemy, 2, 3, 4, 5. And that's it. That's as long as our wave have lasted. We have 5 enemies on screen. We know it's working correctly. So you may be asking yourself, why have we set it up like this? Why have them stop? Why not just kill you? Why not continuously spawn enemies the whole time? Surely that would make more sense. Sometimes you don't want that. Sometimes you want a template for control where you could say, for example, spawn enemies at a specific rate for a specific time because this is wave 3. And maybe when wave 4 happens, you want that spawn time to reset so you can spawn enemies again. Maybe you want to spawn enemies slightly faster as well. So we could actually adjust this float too. And generally speaking, you'd have that all set up somewhere that could handle that. Maybe it'd be a wave spawner script that talks to these various scripts, as well as talks to various enemy spawners in some kind of array. We're not going to really walk into that territory. I'll leave that up for maybe some of the more advanced programmers to investigate. Spawning multiple waves over a set period of time that gets slightly faster. That could be quite interesting. But what we will do is put a couple more of these enemy spawners in. So if you put a couple more in and just move them around the environment, I won't move them too far away. That'll do. You can make the challenge much more difficult simply by virtue of having more enemies in the scene. So this is going to actually, in the next couple of weeks, become quite a challenge, depending on how well your environment works with these enemy hordes.